Hey, welcome back, students. I want to go ahead and show you how to calculate the frequency, the wavelength, and energy in the next couple of videos. We're going to go ahead and begin this video with showing you how to calculate the wavelength. And so we have a sample problem here, and the problem reads as follows. What is the wavelength of a wave of light with a known frequency of 3.4 times 10 to the fifth? So remember, we do have to use the guess method here, where we identify the given, the unknown, equation, and then we go substitute and solve the problem. So let's begin with identifying the given portions of this particular problem. And so those are right over here, 3.45 times 10 to the fifth hertz. The unknown here is usually presented in the form of a question, and there it is. What is the wavelength? Go ahead and identify now the equations. And so we know that the general equation is going to be here. Well, what we're looking for here is the wavelength, which is lambda. We know that the general equation for these types of problems is going to be the speed of light equal to the wavelength times the frequency. And so what we need to do here is rewrite this equation so that it reads wavelength equals to something. In order for us to do that, we need to do the following. We need to come in here, divide by frequency. That will cancel out the frequencies on the right side, but whatever you do to the right, you're also going to have to come and do over to the left. And so we'll do that now. Doing that there then will allow us then to go ahead and take care of this part over here, because all that entire part, all that entire part over here on the right hand side is going to go away, and we can go ahead and replace that with just simply lambda. Okay, and so let me rewrite this so it doesn't look quite so messy. And so what we have here is going to be the following. We're going to have lambda is equal to the speed of light divided by the frequency. And so there you go. Okay, and by doing that now, we now have a working equation in which we can then go in and substitute. So let's go ahead and clear out some stuff here so we can make some room. Let me take care of this, and let's go ahead and move this equation over here to the right side. Now that we've done that, what we need to do then is begin substituting into what we know. Recall, we know the frequency, that's over here on the right hand side, and we also know that the speed of light is going to be equal to a very specific number here. So that speed of light is going to be equal to 3.00 times 10 to the 8th meters per second. And so this number is what's going to be substituted right here, and then the frequency over here at the very end is what's going to be substituted down below. And so let's go ahead and rewrite that again, this time with the numbers. So we'll have wavelength is equal to 3.00 times 10 to the 8 meters per second. And then we're going to go ahead and divide that by the frequency. In this case, it's going to be 3.45 times 10 to the fifth hertz. Now, one thing to keep in mind here is that the hertz is going to cancel out with the seconds, leaving us the units that we're interested in, which is meters. If we go ahead and carry this math out, we come up with the following answer. 869.565, and there's more numbers here. I'll just go up to this point. But if you notice this, even though this is a correct answer here in hertz, what is not so good about this is if it does not have the right number of significant figures. If we look at the original problems, here we've got 3.45. That tells us that we've got 3 significant figures in the denominator, and at the top, 3.00, those are 3 significant figures there. So what we need to do is make sure that our final answer is to the same number of significant figures. And so the first 3 significant figures in this answer is 869. We have to then look at the 4th digit and determine whether this is big enough for us to do some rounding of the 3rd digit. Because the number here in the 4th position is a 5 or greater, that means we're going to look at the 9 and increase that by 1 number, which turns that answer there for lambda, it turns it into an 870. But this time we have to remember to put the decimal. That's what qualifies that 0 at the very end and makes it a significant figure, giving us the total number of 3 digits. And then we would have the answer of hertz. And so this here is the answer for this particular problem.